Thank you very much for being here. Thank you to the PolyConf team for inviting me once again. Real pleasure to be back in Poznan. So hello, thank you very much for coming. I hope this talk will be interesting. It's actually a real, I'm very grateful for this opportunity to get out of England. We've been having a really good time of things lately, and there was some other political vote going on that you might have heard about. So yeah, it's a pleasure to not be in England at the moment. And we'll be cheering on Poland with you all tonight at the bar as well. So yes, my name is, my name is Jack Franklin, that's me on Twitter. There's a link down the bottom which I'll put later on. It's bit.ly/elm-polyconf, which will get access to all the slides and stuff. I'll put that URL up on the screen later on in bigger text so you can grab it as well. But a bit about me, I work at a company called Pusher. Who's heard of Pusher out of interest? Cool. There's no point in me being here. So Pusher is like a hosted real-time API provider. We make it really easy to build real-time features. Please come and chat to me if that's interesting to you. That's all I want to talk about Pusher. This isn't a Pusher talk. I'm here to talk about this thing called Elm. Who's heard of Elm? Again, I really shouldn't be here. Brilliant. That's really cool. But before we talk about Elm, we have to talk about everyone's favorite programming language, JavaScript. Right? Yeah, oh dear. At least it hasn't got monads. So anyway, in JavaScript right now, we have what I would describe as the great tooling problem. That we're building these more complicated JavaScript applications, and as we've built these large applications, we've suddenly found that we need the better tools around them to make that easier for us. What's really interesting to me, though, is this attitude that we've had to. The applications on the web in JavaScript should be really, really simple to build, and we've been working on tools to make that so. You know, big frameworks like Angular through to little frameworks or littler frameworks like React. There's a whole bunch of frameworks all trying to make applications easy to build. And whilst I think this is great, I think we also have to accept that to a certain extent, applications are just tricky to build. They are difficult things, whether that's on the server, in the client, in a box somewhere. It doesn't matter. Applications are tricky to build. And looking at some trends that have kind of been and gone in complex JavaScript applications, we started with two-way data binding. It's still hanging around in some areas. This is where you have a template and you have a value in your JavaScript, and there's a bunch of work behind the scenes to keep these two values in sync all the time. This was so popular that there was actually a proposal to add object.observe into the language to make this much easier. This actually made it into Chrome, a particular version of Chrome, and maybe other browsers before being dropped from the spec. I don't actually know if it's still in Chrome or not, but it has since been dropped. And this was part of the MVC, MVVC, MCV, CV, MMCV, CCC periods of JavaScript applications, which basically, as far as I can tell, boils down to let's replicate Rails. Yeah, and it turns out, funnily enough, that doing this on the browser isn't as good as it is on the server. Now, I've worked with Rails. I consider myself a semi-full stack developer. I like Rails. I like Ruby. It's a nice language. But it doesn't quite work on the browser. The MVC separation works well on the server. Potentially, you might have different opinions. But I think we can all agree it definitely doesn't work well in the browser. So it's been really nice to see this change in approach to more explicit component-based approach. I would say this was probably popularized mostly by React. But this isn't a talk on React, and there are loads of other frameworks that are doing this too. Angular, Ember, Vue, React, and I had to put Cycle in because Andre's around somewhere as well. So this is really nice. We build applications as a series of small components. We layer them together. We can compose components, and we build applications that way. It turns out that's a much better way. It suits the web. And of course, there's also the native web components work, which eventually might lead to us having something along the lines of components in the browser fully supported, which would be really cool, and I'm hopeful we'll get there. What's really interesting to me as well, though, does anyone actually like JavaScript anymore? Because it doesn't seem so. We transpile code, we write TypeScript, we write CoffeeScript. Anyone brave enough to admit they wrote CoffeeScript? This is a brave audience, I like it. So we've done lots of things to avoid writing JavaScript, which is really interesting to me. I don't think JavaScript is actually that bad a language. Maybe that's controversial. But it's interesting that as part of this development towards larger, more complex JavaScript applications, we begin to wonder if JavaScript is the right choice at all. And that's really where Elm begins to come in as a kind of, what happens if we don't write JavaScript? What happens if we can invent a language from scratch, taking ideas from other places that will end up in a better place? And then once we came through the object.observe, two-way data binding, MVC, MVV, CC, VM phase, we started seeing some other patterns emerge that again, kind of popularized by React and the ecosystem around it, but now being taken into lots of other frameworks as well. The first of these should be explicit about state. State in your application should no longer be magic via two-way data bindings, but be explicit. There's a single source of truth in your application, so your state tends to be kept and stored in one place. A view is just a function that can take some state and return you the actual view. I've put HTML here, but with things like React Native or React on the server, this can be anything you want it to be. These functions are pure, so we call them with the same state. We'll always get the same HTML back. What we then started doing, and libraries like Flux and then Redux and all these type of libraries started to explicitly define the actions that can modify the state. So here we have this action add to do, which has a type of user add to do in the text buy milk. From there we then have these actions and we have state. We should define an update function that can take the action and the state and produce some new state. And this function is where we store most of our business logic. And suddenly we've really decoupled the view from the logic layer, and the logic exists in a function that you can just call and test really straightforwardly. And this is kind of described as a unidirectional data flow. So the user clicks, an action happens, an update function is called, that gives us back some new state, and the view then renders that new state. I promise I did this before I knew he was going to be in the audience, but Andre wrote a really good blog post on this called Unidirectional User Interface Architectures, which covers not only the one that I'm going to talk about that Elm uses, but a bunch of others as well. Really highly recommend it. And I did put that in before I saw him on the schedule after me. And with this, we end up with this kind of this way where data never flows back and forth. It always goes round in a big circle. It turns out this is just way easier to reason about. There's no weird two-way data binding thing where you don't know where the data is actually broken. You can track a piece of data and a user action through your system, and this is a really nice way to debug and work with applications. There's also this trend of explicit versus magic. Now, I'm not going to hate on Angular here, but I'd say this is pretty magical. We dump some property onto this random $scope thing, and then that will just be in our views. And tracking when this value changes based on a user action is very, very difficult. A more explicit way, and again, this is inspired by Redux, is that we take in these actions, and if we have, say, in this case, a new user action, we update the state to have that user property in it. But again, if we were working in a brand new language, how would we model this? We could instead define a type called message, or MSG for short, that is either a new user that comes with a string, which is the username, or it's a logout operation. So you can either log in as a user, or you can log out. And then you can be even more explicit because the compiler won't let you not be. So this is an example of an Elm error case where I'm matching on those potential messages in a case statement. And the compiler spots that I haven't dealt with the logout action. So you can't have broken code where a user action isn't dealt with because the compiler won't let you. So that's enough of a precursor. Let's talk a bit more about Elm. As I said, Elm is a language to solve these problems rather than a framework. It's kind of what happens if we just start from scratch, taking in some inspiration from elsewhere, and turn it into a client-side JavaScript framework. Turns out we actually got this answer a long time ago. I think it was Sherlock who said, "Elm, my dear Watson," something along those lines. That is, without doubt, the worst joke in this presentation, so you can relax. It's over. As an aside, there is a fantastic TV series. If anyone hasn't seen it, highly recommend it. But yeah, that was a pretty poor joke. Anyway, so just to be clear, Elm is not the finished article. This isn't a production-ready framework language that you can take and use across everything very confidently. People are using Elm in production. I'll predict the predictable question. I have not used Elm in production, so don't ask me about that. It's not the perfect language yet. Maybe it could be. Every language has flaws. Elm is certainly no exception. And additionally, this isn't a talk where I present Elm as the solution to all your problems. Elm won't make you stay in the EU. It also won't solve every single type of JavaScript problem that you have available to you either. So just bear that in mind. This isn't me getting you to use Elm for every project you've got going on, but I think in certain situations it might be a good tool for the job. And the really cool thing, which I'll keep coming back to, is Elm can almost guarantee that your app will never have runtime errors. And we'll talk more about this as I go through the presentation, but I think this is so cool. This is really awesome. There's a company in San Francisco called No Red Ink who do run Elm in production on quite a big scale, and they say they've generally never had a runtime error in any of their Elm code, over hundreds of thousands of users over months and months, which is pretty cool. So Elm is often described as functional, typed, and compiled. Those are pretty boring. So I like expressive, self-documenting, and robust, which I think are a bit less boring. There is a bit of a learning curve with Elm. If you think there's a learning curve with a new framework, picking up a new language is going to be at least as tricky as that. But I really do think it's worth it. I think even if you go away from this presentation not writing all your ideas in Elm, I think some of the ideas in it can translate into your JavaScript apps as well. So first is expressive, clear code. Thankfully, the previous talks, in fact, both of them have touched a little on functional programming, so I'm hoping we're all a bit up to speed. At the top there, we've got how an add call in JavaScript. Just below it, we've got an add call in Elm. And to map over a list and add numbers to them, we can call list.map. The projected thing doesn't work. The middle list.map creates an anonymous function which takes x and returns x plus 2. The lower one uses partial application to take the plus method that already exists and partially apply it with the value 2. So all the goodness of functional programming you get. The previous talks did a good job of explaining why functional programming is pretty wicked. There's also some nice syntactical things like pipes as well. Often in functional programming, I found myself ending up in the situation on the top line where you have like this make a person call, and you want to pass that into this other function that then passes into another function, and so on. Elm has this idea of pipes, which is the same thing but written in a much more readable manner. And I think generally just Elm syntax is pretty clear. The top function there, increment age, takes in a person. In JavaScript, a person would be called an object, but in Elm we call them records, and it updates the person's age property by 1. And then we define a method add, and again we use partial application to create add2. I don't want to talk too much about Elm syntax because I think it's just something you pick up and will enjoy working with. I'd much rather focus on a lot more of the ideas around Elm. So I'm not going to go too deep into lots of syntax, but there's links at the end to the Elm guides and the syntax guides and all the rest of it. Elm is also very self-documenting, the main reason being that it has types. These are called type annotations. So you can take a function, you can annotate it with the types that it expects to be given and the type of the thing that it will return. The thing on the furthest right is the thing that it will return, and anything prior to that are the arguments it expects. So here the add function takes one integer, takes another integer, and will return an integer. Is even will take in an integer and return a Boolean, true or false. That's really nice. You don't have to use these type annotations, by the way. If you don't, Elm's compiler will figure them out for you. But for the purpose of you and documenting your code, I highly recommend it. It becomes really powerful, though, when we can define union types in Elm. So say we're working in a to-do app, which I think might have been used as an example at some point on the web. Say we have a filter that lets users filter between showing all the to-dos, showing just the completed to-dos, or showing just the active ones. I can define a union type called filter and say that it's either equal to show all, show completed, or show active. Then later on, when I have a function show to-dos, it can take in a filter and a list of to-dos. A match on the filter, if it's show all, we'll return all the to-dos. If it's show completed, we'll filter for the ones that are complete. And if it's show active, we'll filter for the ones that are not complete. This is really cool because they can be checked by the compiler, so you can't ever forget one. If you typo one, that will also fly up as an error. And it's easy to change and add a new one. You can rename one, hope you got it right, but if you didn't, the compiler will help you out. In addition to this, we can also define type aliases. So if we're working with a record in Elm, which is very similar to a JavaScript object in a lot of ways, we might have a person record, which has a name and an age. And I can alias this to be a type person, like so. And now all the functions that take in this record can actually have the type annotation reference the person type alias. So your code here is incredibly self-documenting. More importantly, it's also typed in your own kind of domain terminology, which makes it really nice to work with. You might also notice the comma first approach. This is the direction that the Elm community has chosen to go in, for better or for worse. Hopefully some people get that reference, else that picture makes absolutely no sense. But yeah, it's just the way in Elm we do leading commas, just FYI. Thankfully, there is a tool called Elm Format, which I'll touch upon in a bit, which kind of makes sure that you are good as well. Finally, Elm is also very robust. Every data kind of type in Elm is immutable, and immutability brings some really nice guarantees. I think we've probably all been hit by this JavaScript bug where you pass, or not bug, sorry, this feature of JavaScript where you pass in an object, and that object is passed by reference, so it can be mutated, it can have all sorts of things done to it, and you as the person who passed it to that function just don't know about it. So here, if I have this person object and I call increment age on it, I don't actually know what's going to happen. Does increment age return a new person? Does it modify what I passed in? I have no idea what happens to that person once it's inside that function. In lovely Elmland, though, it's impossible for that to happen because nothing can be mutated. So I know that increment age isn't going to mess with the record I give it. I know that it has to return a new record because it can't mutate the original. And we get rid of a whole class of mutation bugs that are a real pain to track down in JavaScript land. A few more features of Elm, just to touch on. Elm does have a module system. It's not particularly exciting or mind-blowing. Just to mention, everything is scope. There's no concept of like a global variable or state. Modules explicitly declare what they expose, and they explicitly declare what they import. It's not a million miles away from the behavior of ES 2015 modules, if anyone is familiar with that. Elm also provides a really nice way to deal with nothing. The inventor of null or nil called it his billion-dollar mistake, I believe. Elm deals with this by, we don't have undefined or null or nil or any of those variants in Elm. Instead, we have one of the most British terms I've ever come across, maybe. So we have a type maybe, which is either just a value or nothing. So it's either just some value or it's nothing. This becomes much clearer with an example. Let's imagine we're dealing with an app where a user can be logged in or they can be logged out. We might model this user as a maybe user. This means either they're there and it's a user or it's nothing. But because we explicitly model it through maybe, we have to deal with both sides of the condition. We have to deal with the user being logged in. We have to deal with them being logged out. I'm a really dreadful, lazy developer, and the amount of times that I've forgotten to deal with the case of a user not being logged in, or some edge case, is pretty high. But Elm just doesn't let me. I have to deal with it, and that's actually really, really nice. You have to handle all cases of missing and pending data. This is through asynchronous HTTP requests that can fail, users being logged in or logged out. Anything where there might not be some data, you have to deal with that. Elm deals with the asynchronicity of apps using Task, which is a module for async actions that might fail, most commonly HTTP. So a task will, this lower declaration here is a task that will fail with a string, so it will give me back an error message, or will succeed with a user. I won't go too much into the specifics of this module. Again, I've got lots of links at the end. But the takeaway from this is that you have to deal with errors. Task doesn't let you not. And finally, to deal with background jobs like async HTTP requests, Elm provides us with commands and subscriptions. If anyone came to Elm pre-0.17, which was released fairly recently, a month, maybe a bit longer ago, this won't be familiar to you. You'll have seen this thing called signals. 0.17 hid signals under the hood and gave us commands and subscriptions, which are a much nicer way to deal with things that will happen asynchronously and then provide you with some data later on. So command is something you give to Elm that it will run, like an HTTP request. A subscription is, hey, I want to subscribe to this piece of information, and you need to tell me every time that piece of information changes. Subscription could be the dimensions of the window, for example, or the position of the mouse cursor. This does take time to adjust to. There's a lot of new stuff. I'm not expecting you all to pick up Elm straight away and understand it all, but I really think it's a really fun language to work in once you do get used to it. And that is pretty bad contrast. Again, another blog post by this guy, I don't really know, Everywhereness as a Foundation by Andre, says, when you apply a pattern everywhere, it ends up becoming a guarantee that 100% of your code will follow that pattern. I highly recommend this blog post as well. The Elm compiler makes sure 100% of your code is thoroughly is checked against corner cases and error cases. And it's because of this guarantee that Elm programs have virtually no runtime errors, which is really, really cool. Once you get rid of any potential nils and undefineds and all those things, and you type everything, it's really tricky to have an actual runtime error in your code, which is awesome. Again, another really good blog post. I should point out that that is an actual link, so in the slides online, you should be able to click that. If not, the slides are on GitHub. I'll link you at the end so you can grab all the URLs as well. So moving on from the language, I just want to quickly talk about the Elm architecture. So this is how we build applications in Elm. This probably is the bit that's most interesting to you if you don't think you'll ever get a chance to write Elm in production, but do think you might get a chance to take some of its ideas into your own JavaScript applications. There are three parts of the Elm architecture. There's a model, which is all our data. We model all our state in one place. A view function, which can take the model and produce some HTML. And the update, which can take a message, which is like a user action, say log out or add to do. It can take the model and it can give me back the new model. In a diagram form, this looks somewhat like this. We have our view down here. That sends messages to the update function, which generates a new model, which comes back to our view again. And these can be nested deep, and that's how we build nested applications. So to give you a very quick example, we'll build the hello world of Elm, which is a counter application. The first thing we do is define our model. In this case, the only bit of data I care about is actually the integer value of the counter. So I'll alias my model to be just an integer, and I'll set my initial model to be 0. I then define the messages, and these are the things that can happen that might change the state. In this case, we're going to either say increment or decrement. Then we'll define the update function. So it takes in a message in the model. When the message is increment, I'll return the model with 1 added to it, and when it's decrement, I'll subtract 1. And finally, we define the view, which takes in the model and returns some HTML. So I'll set up 2 buttons with an on-click, which will send the decrement or increment action, and I'll have a div in the middle with the actual text value of my model as well. And finally, we use the HTML module, which comes with a beginner program function that we give a record with our model, our view, and our update, and that's it. It does lots of the work behind the scenes to set it all up for you. And if we do that, we do get a simple counter like so. It's pretty cool. All this code, by the way, is also on GitHub too. The really nice things I like about this approach to developing applications, we left the view until last. All our logic was explained before our UI was built, which I really like. And update as a function would be really, really easy to test as well, because it doesn't deal with the view. You wouldn't have to simulate user clicks. You can just call the update function with the stuff you want. Obviously, that's a pretty straightforward application. Once you get to bigger apps and you deal with, say, HTTP, you're going to need to deal with side effects. So pure functions can't ever have a side effect. So a side effect would, change a bit of data or mutate some form of outside state. And in a pure function, we can't have that. It should be given some input, and it should behave entirely the same based on its input and never modify the outside world. So instead of letting functions just randomly kick off HTTP requests, we model them very explicitly as side effects. So we hand them off to Elm, and it will give us back them later when it's got the data. We do this through commands, which I mentioned earlier. Whenever you perform some background work, give Elm a command. Elm will go off, it will run it in the background, and it will come back to you when something's happened. Either it succeeded or it failed. Once we have these, the Elm architecture changes a little bit. The new bit is the update call. Notice now, it takes a message in a model. It actually returns a tuple with the new model, but also a command as well, which is some work that Elm should go and do in the background. If we go and take a look at my really well-designed diagram, the update call now, you can see it can also fire off some command in the background. That command will return at a later date with some data, and it will call the update method or function again. So just give you an example of this. Again, I'll whiz through the code fairly quickly, but all the code is on GitHub. I'm happy to take you through it in person later if it's of interest. Fetching someone's GitHub data. Firstly, I'll define the model. So I've got a GitHub person here, which is a name and a company, and these are just 2 fields that come back from the GitHub API. Then I've aliased my model to have a username, which is a string, and then a GitHub person, which is maybe a GitHub person. You do have to say it as maybe as well and shrug your shoulders when you do it. Then we'll define the messages. So we'll either get a message of new GitHub data, and that will happen when the API has given us some data back. We'll either get, then we'll also potentially get fetch GitHub data, and that's what will be triggered when the user clicks the button. And then finally, we might also get fetch error, which will be an HTTP error if the API fails as well. Thirdly, we'll define the update function. Note this new type, so we're now returning a model and a command. I've ignored the code for dealing with errors. You obviously do have to do that. This wouldn't compile, but I've just left it to save space. In the case that we get fetch GitHub data, we'll return the model, and then we'll return this fetch GitHub data function. That will return us a command that will be given to Elm that will go off in the background and make the request. The new GitHub data message will happen when that request has succeeded, so I'll just update my model to have this new GitHub person property, which is set to being just a person. Because remember, a maybe is either just some value or nothing. So yeah, so these are the 2 important bits. And then when we get the new GitHub data, we also return command.none, which basically says to Elm, there's nothing for you to do here, this is cool. Fetch GitHub data returns fetch GitHub model, which goes, hey Elm, you've got some work to do, go and do it. And just to kind of reiterate, this is roughly what's kind of going on there. Finally, we define the view. So again, I'll match on the case of GitHub person. If it's a div, I'll return some text about that person. And if it's nothing, I'll just return the button, which you can click. Finally, we have to define our init function. This is a kind of an addition to the Elm architecture when you're dealing with side effects, which just says what's my initial data and what's an initial command you want me to run. In this case, we don't want to run a command. The initial data is just what's above there. Finally, we hook it all together using the program function. Ignore the subscriptions bit. That's for if you want to care about extra outside info. In this case, we don't. And if we run that, you will see this does actually work. And we do get Jack Franklin from Pusher. So I realize I'm running out of time. Just go quickly through the last bit. So this is a kind of general flow of what goes on here. The user clicks the button. The update function gets called with the fetch GitHub data message, which returns the new model and the fetch GitHub data command. The view renders. In the meantime, behind the scenes, Elm gets this command that says go and fetch some data. So it will make a GET request to the GitHub API for us. When that returns, we'll get a new message of new GitHub data created. We'll then call our update function again with the new GitHub data. This time, we don't have any more work to do, so we'll return the new model and command.none. And then the view re-renders, and we get Jack Franklin from Pusher. So you're probably all thinking that feels like a lot of code or effort. Hopefully some of you aren't, but that's often kind of one of the first reactions to this stuff. And I think this comes down to boilerplate versus explicitness. A lot of frameworks these days tend to be very magical and do a lot of stuff for you behind the scenes. Elm really is anything is the complete opposite. I think at times it can be a bit too boilerplatey, but on the whole, I'd much rather err on the side of knowing what my app is doing and explicitly laying it out versus having it work behind the scenes for me. So that's something you need to weigh up. Additionally, the benefits of all this structure are much more apparent at a larger scale as well. At a small scale like this, it doesn't really matter what you write it in, let's be honest. But a bigger application, you'll get a lot more of these benefits. Just to briefly cover, I didn't actually cover how we fetch data from GitHub and turn it into an Elm data type. The code's in the GitHub repo. Please come and chat to me if you want to talk about how we decode JSON into Elm records as well. This is your URL for everything in this app. bit.ly/elm-polyconf. I'll tweet it out and hashtag it and all the rest of it so you can find it later on. Talk about scaling your application very quickly. It's basically just this reiterated all the way down. So it's the Elm architecture of the model view update at various levels. So you have big components, you have small ones, and they all just, they each define each one of these functions, and then you build them up, you compose them together. Finally, the Elm ecosystem, just give you a quick idea. Elm comes with some really nice command line tools. First is Elm Reactor, which will just run Elm locally for you without you having to configure anything. So if I'm in a project here, I run Elm Reactor. Then I go into my browser, I refresh, I do this really slowly. It lists all my Elm files, I can click, it will compile it for me there, and then you can just see my little counter app in the top. So Elm Reactor is really nice, you don't need to run any big command line tool to get started with Elm. There's also Elm Package, which is the most British package manager I've ever met in my life. Just check this out. Do you approve of this plan? Yes. And then if I install another package, like Elmlang, the HTML package, get this. May I add that to elmpackage.json for you? Why, yes, you may. And yes, I approve. Yeah, so anyway, I don't believe Evan is British, but that's an incredibly British package manager, and it brings a lot of joy to my life, even if I hate half my country right now. Anyway, Elm Package also deals with semantic versioning for us. Because everything is typed in Elm Package can actually spot when you've changed to what level you've changed your package when you bump a new version. So I've got this module called Elm Statey, which is an Elm state machine library. And I made a fake change here, and I changed the type of one of my functions, make state, from being one that takes a string and returns a state to just returning a state. This is a breaking change. So if I try to publish it without marking it so and bumping it to version 3, Elm Package won't let me. You cannot break semantic versioning when releasing an Elm package. No, it can never break. It can't. It's impossible. We've all installed, was it underscore or something that broke semantic versioning and cried for a few days? You can't do that in Elm. Really cool. There's also Elm Format, very quickly, which will run in your editor and format your code, similar to Go Format and all those other touch tools, which is really cool as well. There's loads I haven't covered. I've got a minute left. The people at the front are getting annoyed at me, so I'll very quickly finish up. So why or when should you use Elm? If you're fed up of undefined function errors taking up loads of time, you're fed up of, is that working? There we go. You're fed up of packages and NPM breaking semantic versioning or not being confident in them. You want to develop with the confidence of types and a clever compiler to back you up. You are happy to ride the wave, as it were, and deal with a language that's still growing, still making changes, still settling into its place. You're happy to build packages then depend on existing solutions. This is a big thing if you pick up Elm. It just hasn't been around for as long as other things. So in React, if you're building a React app, for example, there'll be a lot of components you can just grab from GitHub and run with. Elm is getting there, but it doesn't quite have the same number, so you should be prepared to write more code yourself. What if this talk has put me off Elm? Hopefully not, just in case. There is a bit of a learning curve to Elm. It does take a bit of adjustment, so please don't give up. There is a guide here. It's like a big tutorial, guide.elmlang.org. Highly recommend. And Elm the language brings many concepts that are language agnostic that I think everyone can benefit from. The Elm architecture, the explicitness across your application, this idea of types. I know TypeScript is gaining a lot of popularity at the moment for similar reasons. Just embracing immutability and functional programming. The way we define applications by first defining the model, then the actions, then the update function, and then the view, and just repeat that over, I think is a really nice way to work as a developer. Will everyone be writing Elm in 1, 2, or 5 years? I don't know. Will this be ElmConf in 5 years' time? I personally hope so, but I'm not sure if any of you do. But what I do know about Elm is the game is very much on. Better than the other one, or worse? I think better. Worse? Anyway, a few links to take away. Guide.elmlang.org, there's a few links. The community page has links to the Elm Slack, IRC, all the rest of it. bit.ly/elm-polyconf will get you to the GitHub repo where these slides are and also all the code that I've showed you is. And I've also put the slides already on SpeakerDeck. If you go to speakerdeck.com/JackFranklin, all lowercase or one word, that will get you the slides. I will tweet them shortly as well. So, thank you very much for listening. I've been Jack Franklin, JavaScriptPlanning.com. Come on, Poland!
All right, thank you, Jack. Great talk. I think we've got a few minutes for some questions.
Hey.
Hi.
Thanks, that was a great presentation.
Thank you.
And I think, Elm is definitely one of the most interesting languages at the moment. But just to put on my devil's advocate hat on for a moment, there's a concern that you're basically conflating things, or that Elm is conflating things in two areas. One is that it's not a general purpose language, but a language that is married to the browser. So I was wondering if you could comment on that. And the other question is, you sort of switched around between speaking of Elm as a language and as a framework. So is there an effort to separate out the framework from the language, or are those two coupled very tightly?
Yeah, cool. Really good questions. Thank you very much. The first one was, is Elm only a kind of browser-side language? Yes, at the moment. I think longer term there are plans to move it to a more general purpose language. There is work going on at the moment to run Elm on the server side as well, probably through Node. That is at a very, very early stage. I couldn't comment too much on it. I'm not very close to that. But I think at the moment it's found its place in the browser, but a lot of people would like to use it in other side, even if we can use it on the server for server-side rendering of apps and that side of things. I think that will happen. I couldn't give you a timescale on when that is. The second bit about the language versus the framework, that's a really good point that I should probably make clearer. It's hard in 30 minutes to squeeze it all in. The Elm architecture I talked about is entirely optional. Elm's, there is an Elm package that provides the program calls that I made and passed it all the functions to hook those applications up. You don't have to use those at all. That is separate from Elm, the language, but it's really highly recommended, and it's where most people are focusing their efforts. So I don't think it's tied, but I think Elm as a language will always suit this particular style of architecture, so you're very highly encouraged to use it. That being said, there's no reason that someone else can publish another Elm module that switches things around and does things a bit differently, and if that was better, then that would be great. I think the Elm community is willing to kind of learn as you go on. There's also a really good post on the Elm discussion list where the creator of Elm, Evan, points out that you don't have to follow the architecture, 100%. If there's a point in your code where it doesn't make sense to do so, you should feel absolutely comfortable in, just doing something slightly differently to make your code work, and that's not a problem. It's there very much as a guide more so than something you have to use. I hope that helps, but please come and grab me if it doesn't.
So Elm compiles to JavaScript, obviously, because that's what browsers run natively.
Yeah.
And one of the things that always put me off about those languages is that if something goes wrong, it's very hard to figure out what exactly went wrong.
Yeah.
How does Elm cope with that?
Nothing goes wrong.
Until it does.
Until it does. No, but there is IRC, I don't run Elm at production at scale, but there are a lot of people talking about how they get very few runtime errors. This is one of my concerns when I started Elm, was actually the debugging part of it, especially in the browser. Elm does provide tools to let you log things out to the console and all the rest of it if you want to. I think you'd actually be really pleasantly surprised on how infrequent it is that you need to do that. I've been very surprised at how I don't console.log things anymore and I don't debug in that manner because the compiler does nearly all the work for me. It is possible when you need to. I guess, like, yeah, when you get runtime errors, it's going to be tricky to track down in the browser, but it really happens so infrequently that, you know, there isn't much work going on in that space. I guess, like, the argument would be if an error goes wrong in your minified JavaScript, you'd get the same problem, but then there's source maps. So I don't know if Elm does source maps, actually. But I'm sure, you know, I don't know, it's just not that big a deal, basically, in Elm, which sounds like a really cop-out answer, but that honestly is just the way it is at the moment.
Cheers.
So that was very excellent example of quick application running solely in the browser. But do you have some, let's say, quicks like of showing when Elm grabs something from the backend, yeah, just to see how complicated or easy the API is? Yeah. So the GitHub person example did make a request to the GitHub API, and you could swap that out for your own API. The bit of code I missed in that example because I was short on time, basically, was the actual bit that makes the request. I had that like fetch GitHub data function call, and I never actually showed you what the definition of that was. That's the bit that basically is in the GitHub repo that you should take a look at. There's two parts to it. You have some JSON that you need to change into an Elm record. So we have to decode JSON in Elm using the JSON decoders, which is weird to me. It takes a bit of getting used to, but is really nice because then you can never have misformed JSON that makes it through to your application's logic, because if the JSON is misformed, Elm's decoder will fail and give you an error message instead that you can then deal with. So that's really nice. The other bit is just calling the task module. So you call task.perform, and then you give it like the http.get function, and it will go off and make the request for you. So there's a little bit of code I missed out that's on the GitHub repo. If you'd like to see it, please come and grab me. I'm happy to just open my laptop and walk you through it in person as well. It's no problem.
So just a quick one, pardon my naiveness here. We saw in the slides that the view layer, so the HTML, was Elm code as well?
Yes, yeah.
So is there a way to...
like... Oh my word, it was really far back, wasn't it? Shouldn't have done this, but I'm committed now.
My question was, is there a way to,
yes.
To use HTML?
No. To go a bit further than no, I thought that as well when I started with Elm, but actually it's surprisingly nice to work with this structure. Elm's HTML package does have a few oddities that will take you a bit of time to get used to, but it actually becomes really nice to work with it in this form. I should add that under the hood, Elm uses the virtual DOM kind of in a similar fashion to React and lots of other frameworks, so it does these updates very efficiently. But no, you do have to write this. But I think once you get used to it, it's very enjoyable to work with.
All right, thank you, Jack.
Cool.
We're a little bit short of time. So, again, big applause for Jack.
Thank you very much.